So please unmute your microphone and welcome to our space technology panel. We'll be talking about the space technology, but with connection with the business or small business or technology transfer from the small business to bigger business. We have a great examples of these people from this area from all the world. Some of the people in the US, some of the people in the Poland, and I'm now talking from New Zealand. So welcome everybody here. And I think that we just begin maybe from the Chris Welch, who is head of the Space Payload and Laboratory and Director in Space Student and National Space University. And can you tell me what you are doing, how your sandbox looks, and do you see some of the examples, this small business and big business in the space technology?
Okay, well, I'm a university professor, so I'm not directly involved in business, although ISU itself does. And a lot of our students go on and set up companies and work in the space sector afterwards. A couple of companies that you may have heard of that involve ISU alumni, were founded by ISU alumni, Spire Global, Planet, and companies like that. And so at ISU, as well as providing the education, we now have an incubator in our building, and we're pursuing startup activities. From my perspective, as a professor, more involved with the research and the education, the big thing that has changed over the last 10 years is the cost of access to space for small payloads, and also how cheaply they can be manufactured. So, for instance, at the moment, I have a payload on the International Space Station. It's admittedly a very small payload. It's 10 by 10 by 10 centimeters. It's been up there for 2 years now. And it cost us in total about 3,000 euros to build in terms of components. We use commercial off-the-shelf components. We use 3D printing. We use very simple manufacturing techniques. So that was good from the point of view of designing and building the payload. But what has changed is how cheaply you can get a science payload into space, for example. This was pioneered initially by nanoracks, who were the first people to do this, who acted as an intermediary between customers and the launch providers, and obviously the people who run the space station, whether it's the American part or other one. But now there are similar services. And I think that makes a big difference. For 50,000 euros, you can send a 1 kilogram, 10 by 10 by 10 payload to the International Space Station. And it is almost as simple as just, handing over your credit card details. Back when I started my career, if I wanted to fly something to the space station, I would have had to make a proposal. It would have had to be peer reviewed by multiple committees. The space station agency would have had to approve it. And who knows, maybe 5 or 6 years later, I could get my payload to fly. So this is allowing for lots more people to try things out in space. It's the ability to do something new on a small scale relatively quickly and relatively cheaply.
Okay.
I think that, for me, that's the big thing, at least for payloads on the space station.
Okay, so just clarifying, I understood that you have this payload is just mounted on the space ground station. International Space Station. It's not just the program was sending CubeSat from the International Space Station, correct?
No, you can launch CubeSats from the International Space Station, and nanoracks are the people who have pioneered that. They get carried up there, with the astronauts. And then they're put in an airlock and sent out of the airlock. But you can also fly payloads to the space station, which are installed inside it.
Okay, good. Now maybe we go to Shanwa, who is the scientific astronaut candidate from Canada. Can you tell me something about this? It's just I understood that Canada has done the program for sending humans in the space. Can you tell me something more about this?
Yeah, absolutely. So it's one of the many hats I wear. I'm a physician by training. As you said, I'm in Canada, and I've been involved with Project Possum as a scientist astronaut candidate for 5 years. So like everything in the space world, it is an acronym which stands for Polar Suborbital Science of the Upper Mesosphere. And the initial mandate of this program started out looking at aeronomy, the science of the upper mesosphere, And the initial mandate was to study clouds high up at the 80 to 100 kilometer upper mesosphere, a specific type of cloud thought to be related to climate change called noctilucent clouds. And what we know is that they're a relatively new phenomenon on the meteorological record, and that they're more pervasive and more prevalent since they were first noted, since the late 1800s. And the initial mandate was to train citizen scientists to get more data, capture more high-resolution video, photo, atmospheric sampling in a suborbital vehicle. And so that was the initial mandate. Candidates can apply if they have a STEM background. A pilot's license is nice to have, but not need to have. The other requirements is a scuba diving license. And then they attend the ground school, which involves, learning more about the science of these clouds, undergoing the mission profile in a flight simulator, undergoing aerobatic flight, undergoing slow onset decompression in a hyperbaric chamber, because that's the kind of thing that could kill you in flight. And, the whole mandate is empowering citizen scientists. So having people who are smart, who are driven, who have a passion for this kind of thing, but who may not necessarily have their PhD in aeronomy. So that was the start. So POSSUM has now tremendously expanded in the past 5 years. So our official academic affiliate is the International Institute of Astronautical Sciences. We have courses related to parabolic flight. I've been part of the parabolic flight microgravity campaign for the past 5 years. I am the operational chief instructor of the operational space medicine course, and I am also the director of the International Institute of Astronautical Sciences Space Medicine Group. So I also get to bring my own expertise to this organization and empower other citizen scientists to learn more about space medicine as well. So I'll leave it at that in case there's any follow-up questions, but happy to talk more about this.
Okay, can you tell me? Can you tell me more about this program in Canada? The Canada just plan to send one astronaut, or have some plan to creating some group of astronauts? How it looks?
Yeah, sure. So to add some more clarity to that, so this is separate. This is a not-for-profit bioastronautics organization based in Boulder, Colorado, which I think is where Shelly is. And it's a very international organization, even if it is based in the US. And the whole idea is, democratizing access to space. I like to say there's space for all of us. So you don't have to be a physician. We have pilots, we have military veterans, we have PhDs in fluid thermodynamics, and the whole commonality is that people are driven, team-oriented, and very, very smart and very operationally good. And so it's not just about sending one person, it is about facilitating that access and doing some good science while we're there.
Okay, and can you tell me something about how, if you are possibly in this training for the astronaut, is just this training is just organized only for the, I say, some government institutions, like I'm not sure, university, maybe some the space agency, or it's rather some the small companies, business companies, some business to education cooperation. How it looks?
Yeah, so I should clarify that we are not, we are not a NASA, we're not the CSA, we're not a governmental space agency. We've certainly partnered with them. We partnered with the Canadian Space Agency last year to test EVA spacesuits, extravehicular activity spacesuits in their high bay. So we have lots of partners like this. We've partnered with industry, we've partnered with Survival Systems USA to do our water training. We partner with academia. We've partnered with SWARI, for example, to do some fluid thermodynamics testing in zero-G. So it's, again, comes back to that theme of inclusivity. So whether you're a governmental space agency, whether you're a private citizen, whether you're a commercial entity, whether you're academia, if you have, if you fit that mandate of wanting to make space and science more accessible, contribute to science, and work together while doing so, then, we're always happy to collaborate.
Okay, great. Okay, maybe now we switch to the Robert Zubrin, Dr. Robert Zubrin, who is just the pioneer in astronautics, and president of Mars Society. Robert, can you tell me, because I understood that you just the pioneer just to go to the Mars, I say, and creating some the proposition, and I say that a lot of people just follow by your, I say, the imagine how can go to the Mars. Can you tell me say more about this? I not hear you. Robert, I not hear you. Anybody hear Robert? No. Okay, so we need to fix the problem with your microphone. Robert, I not hear you. Sorry. No, now you are mute. Okay, my proposal is just you leave the meeting and come back again. Maybe it's fix the problem, and maybe I go to Shelly.
Well, hi.
Because Shelly's in the US and understood. Yeah, and maybe you show me some examples from your side. Shelly is just the CEO and executive leader from the Center of Innovation and Education, so it's rather close to the Chris Welch probably, but in the Space Foundation, so probably some women's. Tell me more about this.
I'd love to. Well, thank you very much for inviting me. I'm honored to be joining our esteemed panel. As you said, I'm Shelly Brunswick. I'm the Chief Operating Officer at the Space Foundation and our Executive Leader for our Center for Innovation and Education. If you're not familiar with the Space Foundation, we are a nonprofit located in the US. However, we do business internationally. One of the things we do that many people know us for is our annual Space Symposium, where we bring the global space community here to Colorado, military, commercial, civil, international, to talk about and lay the policy for the future of space. During COVID, we've gone online with that, with our virtual 365. So we hope to see you joining us on some upcoming events. However, as you mentioned, I am the executive leader for our Center for Innovation and Education. And that is really about breaking down barriers, creating inclusive, sustainable, innovative programs to allow workforce development and economic opportunity so all citizens can participate in the global space economy. Specifically, when you think about entrepreneurship, the global space economy is $424 billion, and that's projected to grow $1 to $3 trillion in the next 10 to 20 years. And we need everyone to look at being an entrepreneur or being part of a space company, whether you're an astronaut and PhD or you're manufacturing sector, artist, financial manager. One of the programs that we have is our Space Commerce Entrepreneurship Program, and it is designed to help allow entrepreneurs to enter into the space economy. We have a workforce development roadmap that has 5 phases, and the first one is awareness, and that's what today's program is about. Learning and being aware that space is an opportunity for you. The next thing you can do is we call it access. How do you access that? Well, you can access it by coming to the Space Foundation 365 program. You can take classes with ISU. You can connect with other like-minded individuals through Women in Aerospace in Europe or in Canada or in America. And then you get the proper training. And so we have some videos online that are free if you want to be an entrepreneur. I put the link in the chat. You can look at those webinars to see what does it mean to be a space entrepreneur, or you can take a class at ISU. And then it's about connecting, coming to events like this and connecting with the global space community. And last, or actually I say first, find a mentor. There are wonderful mentors out there. I am a UN Space for Women mentor. Women in Aerospace has mentorship programs. Women Global Tech has mentorship programs. If you find a mentor, you will find somebody who can help you unlock your potential in being an entrepreneur in the space economy. So I'll just pause right there, see if there are any further questions.
Tell me, I have the question. Tell me, first question is just, where's the source money from in US for this business? It's just the local business? Is just the government contracts? How it looks in the US?
So for U.S. space entrepreneurship, there's a lot of opportunity, and there is multi ways of getting funding. Obviously, the first thing you want to do is you want to sit down and decide what is your business plan, because whether it's the government you want to get money from, because there are small business innovation resource grants and funding. There's also venture capitalists, there's equity, there's debt, and every one of those different types of funding, though, is going to require something from you. But before you can even meet with somebody, you are going to have to sit down and work through what is your business plan. And I always like to just say, what is the problem? What is the solution? And why is your solution better than anyone else's? Why is it revolutionary? And once you can understand that, then you can build out your business plan and reflect the money. So there is funding right here in Colorado. We have several venture capitalists. State of Florida, Texas. I'm in Chris's ISU class this week, so we have people from all over the world. There's lots of funding opportunities, but it is competitive. So you really, before you even think about the funding piece, you need to understand what the problem is and how are you making a solution that's different than anybody else's. How is it innovative, and it's going to be a disruptor.
Okay, and can you just show me just one example, what your favorite example of this business?
Absolutely. So for our space commerce program, what we did is we initially partnered with the Minority Business Development Agency, which is part of the Department of Commerce here in the US. They provided the opportunity for us to bring a lot of minorities into the space economy, and we brought them to our annual space symposium and scheduled meetings for them to meet with space industry executives. One company in particular, after going through our program, they redid their strategy, they changed their vertical integration, and they walked out with multi-million-dollar contracts, both with the government and with industry. And so again, before you even start talking about the money, you really have to understand your strategy, what is your business plan, and then it is best if you can have a dual-use technology that is both government and commercial use.
Okay, great. It sounds great. Okay, Robert Zubrin, do you hear me now?
I can hear you. Can you hear me?
Yes, great. I hear you, and you just connect the camera again. So maybe go to you. I say again that you are the pioneer astronaut, astronautics, and president of the Mars Society. Can you show your sandbox, how it looks, and what is the source of money in the Mars Society?
Okay. Well, you're seeing one of my sandboxes right now, which is my home office.
A lot of books.
Yeah, well, I've written a couple. The Case for Mars, The Case for Space, from this room. Now, but the way I actually make a living is with Pioneer Astronautics, which is a small aerospace research and development company that I founded in 1996. We have about 20 employees, and we're currently working on about 8 contracts, about 5 of them from NASA and 3 from other sources. Now, we've worked a lot of things, but the majority of them have been in the area of what NASA calls in situ resource utilization. I call it local resource creation, because I don't believe there's any such thing as a natural resource. I think there's only natural raw materials, and it's human ingenuity that turns materials into resources. And a place is habitable if you can turn the materials there into resources for you. You know, a lot of companies are, of course, SpaceX is developing the technologies to get us into space, New Origin, et cetera. There are other companies developing technologies for operating things in orbit or in transit. Our emphasis has been on planetary technologies. That is, because I believe that it will be possible to develop space when you can use the materials that are there. So a lot of work, of course, on making propellants on the moon or Mars or asteroids. And of course, this concept is central to the Mars Direct plan that I proposed back in 1990, in which, not the exact plan, the principles of it have been accepted now by NASA and SpaceX. Of course, its plan for doing Mars missions is central to that, is making the return propellant methane oxygen on the surface of Mars. And also metals. We're doing a program to produce steel on the moon. Right now, this is the kind of thing we've done. Most of the funding has been from NASA, but it is, I believe that of all the space technologies, the ones that are most likely to find application on Earth are those for utilizing space resources, because then you can discover how perhaps the same technology might be applicable on Earth. In fact, the one space technology that has come into very widespread use on Earth is solar energy, which, because there's a lot of ways you can make power on Earth. You make waterfalls, you can burn things, but in space that's not around. And it was first for spacecraft that solar energy was perfected, and that is now, of course, one of the principal's hopes for the future.
Yeah. But question is, why you are doing this? You are doing this because you want to study this subject, or you want to go to the Mars, or maybe you just want to creating the company who are just producing the money? What is your purpose for
well,
your
there's easier ways to make money. If you have a technical education and want to make money, become an advisor to a stock brokerage or an investment fund or something. Certainly don't start a rocket company, or a company that is promising someone that you can develop something that's never been built before. It's because I'm pretty sure the very large majority of people that work in the space business believe that it is fundamental to a positive human future that humans expand into space. Okay, there's two futures that we see on offer now in movies and fiction. It's either the Star Trek future or the Soylent Green future. We either have an unlimited future or we have a limited future, and they both have very strong implications for the general nature of the human future. And we want it to be an unlimited future. We want this to be a future of possibilities, a future fundamentally, in a fundamental sense of freedom, where you can do new things. There are people who actually want to be astronauts. I wouldn't mind being an astronaut, but to me, it has never been central to my interest that I get to go. Okay, for me, I'm a person who wants to have a purpose-driven life, and my purpose, is I'm a secular person. I believe my purpose is to contribute to human progress. I believe in this very old-fashioned idea, the idea of progress, and I am a soldier of progress. And I think that one of the most important areas of progress in our time is the opening of the space frontier, and that's why I'm very happy with my work. I'm not a person who staring at the clock, wondering whether it's going to be 5 o'clock so I can go home and live my real life. Okay, my real life, well, includes things at home, but also very much includes my work. I am, I'm living my life while I work.
Yeah, okay. I fully understood this. Okay, tell me, because I say that your name is probably so famous, like the Elon Musk. I say that probably you are the second person which if I just need to enumerate people who just have some access to the space now and just creating this space environment for everybody. Do you meet Elon Musk on the coffee and just discuss with him how to fly on the Mars, or it's just rather that Elon Musk have own plan, and you have own plan, and there's some the company I say like the Mars One who have the absolutely other own plan. How it looks?
Well, I know Elon Musk. I've known him since 2001. I don't meet with him on a regular basis. I meet with him irregularly. I exchange emails with him every couple of weeks or so. So I'm not close to Elon Musk, but I certainly communicate with him. I did help recruit him to the cause. Back in 2001, he came to a Mars Society fundraiser in the Bay Area, and it was a $500 a plate dinner, and we got this check for $5,000. And who's this Elon Musk? Never heard of him. And we researched him a bit, and discovered he was the head of PayPal. So I made sure I had a 2-hour cup of coffee with him before the event, and and then he joined the board of the Mars Society, and he contributed $100,000 that helped us build our Mars Desert Research Station. But then after a while, he said to me, "Look, I'm not the kind of person that wants to be part of somebody else's operation. I need to lead my own operation." And he also said, actually, it's a very interesting conversation. Look, I've made all the money I could ever use. So for me, the question now is, what am I going to do with the rest of my life? Here I am, I'm, like 31 years old or something. And what do I do now? And he thought he was debating between two possibilities. He wanted to do something important for humanity, and it was either going to be Mars, okay, and so influenced by my book, The Case for Mars, or solar energy, which he believed was critical technology for the human future. And I argued for Mars. I said, look, solar energy, the commercial possibilities are clear. If anybody can develop a more efficient form of solar energy that is competitive with fossil fuels, it will take off. And anybody who can go to Wall Street with a credible business plan in that line will get investment. Whereas the business case for Mars is not so clear. It's going to take somebody with a higher vision than just chasing dollars to go after it. And well, in the end, he decided to do both, and also did the car company too. But now, if you look at the SpaceX plan, part of it is influenced by my technical ideas, notably the central idea of the use of in situ propellants, which enables direct return from the Martian surface, no motherships needed, no orbiting Mars space stations and gateways, and all that's just direct to the surface, direct return by making use of Martian resources. Other aspects of the plan are quite original and do not come from me. And certainly, look, Musk's accomplishments are his own. Okay, in order to actually do these things, he's had to exercise tremendous business talent, and one might also say political talent, because he's playing with the big boys in a very tough game, and some of them tried to shut him out of the Cape Canaveral launch site, and all. He had to fight all these fights at once, and so I lay no claim to any of Musk's accomplishments. But Musk looks around for good ideas, and he takes those that he finds, and some of them have been mine. There it is. But okay. Musk's an interesting character, yeah.
Yeah. Okay. So tell me, when we land on the Mars with the people, when people just, I say, when we just this day when we just mount the flag, and when will be this day when we creating some the base and start life on the Mars?
Oh, when will this happen? That's your question?
Yeah.
Okay, I actually believe that we're going to be on Mars by 2030, even though you won't find that on any NASA planning chart or any ESA planning chart, anything of the sort. But the reason why is, well, because of this entrepreneurial space revolution, which has been led by SpaceX, first and foremost, which has proven that it is now possible to do things in space, led by entrepreneurial teams, in 1/3 the time, at 1/10 the cost that had even previously been thought normal. And and even do things that have been deemed impossible altogether, like reusable launch vehicles. And, you know, NASA's human spaceflight program has been, you know, kind of rudderless since the end of Apollo. They've episodically have goals, but they change with each administration. And but Musk's goal is very clear. He wants to send humans to Mars, and he's developing this Starship. This is a fully reusable heavy lift vehicle with a capacity comparable to the Saturn V moon rocket, but offers prospects of 1% the launch cost because it's going to be reusable. And okay, he says it's going to reach orbit next year. Maybe, but more likely the year after that. And even if it's the year after that, if Starship is regularly flying to orbit by 2024, whoever's elected president in that year is going to look at his or her advisors and say, look at this. See, can we have people on Mars by the end of my second term and using this? And they're going to say, yeah. And is it going to cost hundreds of billions of dollars? No, it can probably be done within existing space agency budgets. There's a bunch of things that needs to be developed. He's developed the biggest thing, the transportation systems, but we need surface nuclear power. We need other surface systems and so forth that he doesn't have. We can bring that to the table, meet him halfway, and yes, we can be on Mars by the end of your second term. And they say, well, then let's do this. So in other words, by making this possible, he's going to make it sellable, and it will sell itself. And in other words, the leadership from this is going to come from the entrepreneurs, and in particular, this very determined entrepreneur, and that will then bring the somewhat disorganized political class in its tow.
Okay, it sounds great. 24, it sounds absolutely great. And maybe now I go to Nina, because she's just the astrophysics and entry medical student. So what do you think about this? 24.
24 to orbit by 2030 to Mars.
Yeah, okay. Can we go there? And there's some limits for the people.
Yeah, hello everyone. So by trade, I am learning to be a doctor, but in a previous life, I did a physics PhD and moved into medical technology with MRI imaging. And yeah, I'm big on space medicine, bringing the physics and medicine together. And I think there are so many challenges physiologically for humans to survive a long-term mission to Mars. But we're working on it, and there's so much technological advances being made. Everything from kind of radiation mitigation, you could be thinking kind of sci-fi gene editing, or you could be looking at prophylactic chemotherapy. There are so many options that space agencies and commercial entities are looking at. On a personal level, I've been involved with a really good example, I think, of kind of that collaboration between government, commercial and academic. So there's a study called the Myotone study on the ISS measuring muscle health, and I've been working on validating a myometric device to use on astronauts, but it also has terrestrial applications, so sports injuries, deconditioning in ICUs, and I think that's the key to making progress. If you can show that these medical technologies can be used on Earth, people are going to want to fund them to use them in space as well. So that kind of speeds up, it pushes to revolutionize technologies and then also justify the funding as well. So I think that's a really important concept.
Okay, and do you see some examples for small business which can participate in creating this, I say, this travel to the Mars?
Yeah, definitely. I think a lot of spin-off companies come out of academia. So the Myotone Pro is from a university in Estonia, and now they have their device on the ISS. I mean, that's like the ultimate goal, I think, in medical technology at the moment. So definitely, you just need to get some thinking heads together, and multidisciplinary medical engineers, business people, all together thinking outside the box to make it work.
Okay, so who is paying for this instrument on the ISS?
So that's what I mentioned about kind of justifying the cost. I think you can get research grants to develop technology. If it's got a use on Earth for people down here, then you're going to be able to justify making that technology to further space exploration as well.
Okay, great. And now I just switched microphone to the Natalia, who is the aerospace leader and UNOSA Space Forum and mentor. So what do you think about this, everything? We going to the Mars, staying on the Earth?
Yeah, so firstly, I want to share that it's a great pleasure to be to listen to a presentation of all the panelists and to be this panel, and also that's proven by the growing number of viewers that are keep joining. So hello everyone. I am by background, I come from a slightly different background. I come from aerospace, more jet engine design, but at the moment I work for a company called In Space Missions. This is the company which is the prime contractor for satellite building, so I'm more closer to Earth than Mars. Although I did investigate during my course at International Space University, under the guidance from Professor Chris Welch, I did investigate the future of the transportation around the cislunar transportation, namely the cycler. And my work was mainly oriented in finding out whether it's achievable to build it at the moment, and will that give any return on investment in the next decade. So not as close to Mars as I wouldn't like to compete on my views on Mars transportation with Robert Zubrin, of course. I think this is possible. I'm really strongly supporting that. As for my research about the cislunar cycler, I think, as Robert was saying, that if there's someone devoted to the cause that will spend their money not only to chase the dollars, but also to create and to invent something new for the bigger purpose, then it would be possible, although the current state of the technology is yet to be developed. And we need to investigate numerous problems related to, for instance, launching to the orbit and joining this kind of cycler, the purpose for having any goods or people being transported. So I think there's still yet a lot of opportunities for development in the next decade. And as this panel is also to encourage everyone to join the space industry and to invest in these technologies, then I think there's quite a lot of possibilities in here.
Okay, thank you. And now we go back to the Chris Welch, because you are an academic, I'd say, but with the engineering background. We are thinking that, you know, the Mars is nice future when I think about this. It's nice to go there, but what is real challenge for the next years? I say that we should more invest in space technology on Earth, or maybe some space technology on the Mars, maybe some space technology on the maybe Moon, because a lot of people just going now on the Moon. What do you think about this? Where is the future of space technology?
Well, I don't have any particularly strong views about any particular direction. I mean, there are clearly a number of pathways. The critical thing, as Bob said, was, you know, that we get off the planet and that we find sustainable ways to do this. Now, when I was younger, you know, in my teens, you know, I landed on the moon when I was 9. I thought we would go back into space and land on the moon and do all these other things because it was the right thing to do. Turned out that I was wrong about that. And I think it has to be said that commerce has turned out to be a much more sustainable motivation for a range of activities. So I think what we need to be looking at is a range of pathways that lead us to sustainable commercial use of space across a very wide range of technologies. Some of these are easier to make the business case for. Satellite applications, you know, communications, remote sensing, they obviously have value, but there's plenty of scope for innovation. And I think that's what we're looking for. We're looking for innovative niches for new businesses. And that's what I would say is the general approach. You know, I have my favorites. I might be right, I might be wrong. I mean, for example, there's a new project which I think we'll all be hearing about more in the coming months. It's a reality TV show called Space Hero, and it's going to be a big show, global, and the winning prize will be to send somebody to the space station for 10 days, you know. And some people in the space community I now go, oh, well, this is awful. It's, you know, tacky commercialization and it's changing the role of the Earth. But yeah, that's how we know that we have succeeded. When normal people can get to go to space, when it becomes the sort of thing that TV programs are made about, then we know that space is becoming sustainable and more democratic. And I think that's what we have to do.
Okay, so I understood that the space should be for everybody. But
Ideally, yes. I mean, it's difficult, but yes.
yes, it's true. It's Turkey is open, but still probably I say that more access have the people who have just the money. So maybe we switch back to the Shelly, and maybe Shelly tell us, what do you think about this game, this future game, just goes in the space business on the Earth or on the Mars, on the or on the Moon, maybe other. It's just rather for everybody, just for all of these countries, and just working together, or rather it's just for the big players like the US, China. I'm not sure. Maybe some countries like the India, they have some big programs too, or some countries like the Europe, like the France or Germany. So it's democracy in the space, or rather it's just I say, big competition between big players.
That's a really interesting question, but there are more and more countries joining the space community. There's more than 84 countries now part of the global space economy. Yes, some countries are like the US and Russia and China that have a larger presence in outer space, but there are emerging countries in Africa that are using space technology now to protect their wildlife, to look at their natural resources, agriculture, precision farming, and so on. So there's an opportunity for all countries to play and benefit from this. And the part that the Space Foundation we really like to look at is, it's wonderful to have that forward-looking vision to go to Mars and beyond. But what we really like to look at is, let's look at the technology that's coming from those visions, and how do we take that technology and use it here on Earth? And that's where there's an opportunity for entrepreneurship across the board, the democratization of space. So when you look at GPS, that was a military program. It's now commercial, and it's over $1.4 trillion economy. And you can get a phone and create an app and become a billionaire overnight, right? Uber was created based on GPS. So the opportunity to be an entrepreneur, there are 16 different sectors: finance, agriculture, the Internet of Things, healthcare. So there are opportunities across the spectrum for everybody with different backgrounds and different excitement. But I still need Robert saying we need to go to Mars and beyond, because that inspiration, that seed money, that funding is going to drive innovation and technology. And then that technology can be commercialized and used to better our life on Earth. So yes, 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 yes. All countries can play, all citizens can play. We want everyone to find a place in the space economy.
And I'd like to add something to that. The Mars Society, one of its activities, we hold these robot contests of Mars rovers in the desert near our desert station. And about the third time we did it, a Polish team showed up. And the first time they entered, they did terrible. The second time they entered, they came in the middle of the pack. The third time they entered, they won. And since that time, Polish teams have been entering robots into our Mars rover competition every year, and placing first, second, or third every year. But more to the point, some of them have gone back to Poland and start robotics companies. Some of these university students, I think they were from Wrocław, went back to Poland, and based on their designs, they've been inspired to get into this field of technology through the challenge of developing robots for Mars. Now they're developing robots for Earth. And I think Poland is developing a significant expertise in the robotics area, and which, of course, is a very important technology for space, but has infinite applications for Earth.
Yeah, I write with them because I see this the specialization in Poland when we, especially in mechanics, there's this robots competition, but Poland sending a lot of I say hammers and penetrators in space. So this is just the Polish specialization. Some area when we can just do it, it's very good and quite low money. So it's great. So it's absolutely great, and I agree with you, Robert. And maybe at the end, I just talk a little with the Shanwa. If you have to choose, where you want to go? Want to go on International Space Station, or rather you want to go to the Mars, or rather you go to the moon, or maybe you want to go on some asteroid and looking for some new particles there. What do you think? Where you want to go?
So, I will preface this with saying that space is hard, space is risky, space is expensive. So you can send me wherever you want as long as you prove to me that you have the contingencies for any type of, that you've thought through the risks. So when we talk about sending humans to Mars, we can figure out the engineering all we want, but we also need to address all of the space medicine challenges. We need to talk about how we're going to enable these astronauts to live autonomously when there can be up to a 46-minute round trip delay. We need to talk about protecting them from radiation, from altered gravity environments, when we know when our bones and our muscles can decompensate. How are they going to deal with the isolation and confinement? And finally, just the hostility of the environment with altered day-night cycles, increased dust, for example, on the moon. So if you can prove to me that you have thought through all of those things and you have a contingency for that, I will happily go to Mars, and I will help establish the medical infrastructure there.
Okay, and so I just switch again to our to Nina, who just study this space medicine, and where we can send the human.
Well, we know we've been to the moon, but I don't think Mars just yet with space medicine. But I think it will happen in my lifetime for sure.
Yeah, because you know that I just lastly I studied this problem, and you see that sending people on the Mars is just like the suicide for now. There's the problem, the radiation. There's the problem with the some transport people.
Well, I disagree with that. Yeah. It's certainly not suicide. It's certainly risky. But frankly, look, there's a fundamental question here, which is, what is the good life? Is it one of comfort and security, or is it one where you have a chance to do great deeds? Now, they're both valid goals for a life, but if you want to go to Mars, you should be one of those who believe that the good life is one where you have a chance to do great deeds and where comfort and security are very much secondary. If you want a safe job, don't become an astronaut. Okay, there are plenty of other jobs, worthy jobs, that are much safer. It used to be said being a medical doctor was one of those. Right now, it isn't. But anyway, yeah, sure, it's risky to go to Mars, but actually, the radiation risk is not one of the principal risks at all. The radiation dose of going to Mars one way is about the same as 1 year at the space station, which people have done. There are plenty of risks of flight risks. The booster could fail, the flight vehicle could fail, the life support system could fail, the landing systems could fail. There could be accidents on the surface. But when we go to Mars the first time, it's going to be risky. But nothing great has ever been accomplished without risk.
And if you have you in the microphone, what do you think about the programs like the Mars One? Just send people in one way, just creating from this.
Okay, those are two different propositions. Okay, one-way trips or Mars One. Okay. Mars
Okay.
1 was not a realistic venture. Maybe it was realistic attempt to get a TV reality show. I mean, I think they had a finite possibility of achieving that as a business objective. They had no possibility they would send humans to Mars, and their design was not in depth. It was not serious. And they had no reason. They didn't have any realistic plan for raising the money to send humans to Mars, even at a very reduced budget estimate. Okay, so Mars 1 was not real. But but in terms of one-way travel, I mean, look, we're all on a one-way trip to somewhere. You know, and you know, if you don't go one way to Mars, you're going to go one way to Earth. I mean, you know, and you know, my ancestors came one way from Russia to the United States, and I'm very glad it was a one-way trip. Because the relatives that stayed behind were all killed, and but that's not the point. I mean, settlement is a one-way trip. Okay. Now, I don't believe that the first missions to Mars should be one-way missions. I think we should send exploration missions first, and then establish a Mars base comparable to the science base at McMurdo Sound in Antarctica, where we have people staying there for, you know, 3 years, 5 years. But eventually, yes, people will go one way to Mars, and people will be born on Mars. And a lot of people born on Mars will wonder why anyone ever wanted to live on Earth, where the gravity is 3 times what it ought to be, and you know, so forth. And so we're all on a one-way trip, and you know, when it becomes a reasonable proposition to stay on Mars and to raise families on Mars, people will certainly go to Mars one way.
Okay, and maybe just back to the Chris, because you know that when we start exploring the Mars, we just moving the dirty and some, you know, we move the life on the Mars. So I see some of the scientists who just say Mars should be clean. We need this Mars for study the basic of the life in the space or something like that. And we have other people like the Elon Musk who just want to go there, want to transport the people, just creating the base, he wants to transfer this Mars to second Earth. So what is the better way for this area and this activity?
Well, I'm not the right person to answer that question, because what you're actually
you're popular in science, so maybe you can.
No, because what that is, that's an ethical question. That's yeah. You know, and I'm not an ethicist. I mean, yeah, I mean, the same principle applies to any of the things that humans have done in the past, where they have arrived in another part of the world, and you know, they have had an effect. And sometimes it's been a benign effect, and sometimes it hasn't. So, you know, we don't know if there is life on Mars. If there is life on Mars, what are the ethical implications of humans going there? I don't know. You know, I know there are, you know, professional space ethicists. I mean, the French space agency CNES is unusual, as far as I know, in the world, as being the only space agency that has its own ethicist to rule on matters. But, you know, ethics is a matter of human opinion. You know, I'm a physicist turned engineer. I believe in things you can measure with experiments. You know, yeah, they're interesting discussions, but I don't have a, you know, personally kind of strong opinion on, you know, I can see that there is a question to be answered, but I wouldn't presume to be the person to answer that question. You know, I personally, I would be upset if no human beings ever went to Mars. You know, if the decision was made, no, we must not land anywhere that might have life. I can understand, you know, the argument for that, but I would be very disappointed, since, you know, since childhood I wanted to travel off and explore space. So for me, that would be a tragedy. But in the bigger picture, you know, it's a question for you know, for debate and for ethicists and policy people to resolve.
Okay, maybe
unless of course, you know, somebody goes to Mars first, and it's all a moot point, which is certainly a possibility.
You know, and maybe just at the last in this meeting, because you know that we have last 4 minutes. Maybe go back to the Natalia, and Natalia, maybe you tell me like the human. What do you think about this? We be thinking about, you know, exploring the space like the human. You mean that's for human or something like that, or rather we just going there where we have the money and we absolutely not care about the life on the Mars if we just want to build some the base there and creating some the money, or we go to the moon because there will be the helium's free and this can be just the fuel for future. What do you think like human?
It's a very interesting question. And again, following Chris, that would be more ethical question. I can share my personal opinion. I would really like to see humans striving to go and set up a base in the outer planets or even in the moon, Mars including. I think also need to mind the what is driving us as a humanity. So I would prefer if those are innocent views of exploring other planets, and we must make sure that we don't destroy them as well if there is any life we should study, though the commercial reasons sometimes might not be that idealistic. There's an interesting series on Netflix that you could watch, I could recommend, which is called Mars. It's Robert Zubrin is featured in there, actually. There's a study of also the ethical question, but also how the Martian technologies can be related to what is happening at the moment on the Earth. So, for instance, preserving the nature and the conflict of interest between the commercial sector and the academical sector, let's say. So whether it's sometimes worth to preserve some areas for studying instead of just exploiting. So those are questions open to debate, of course, and everybody would have a different view in that. Yeah, summarizing, I think I wouldn't maybe go to Mars myself, but I would like to see that those technologies are being developed and that people are striving to explore other possibilities.
Okay, and I think that people will debate on this subject until the year 24 comes and people just land there and we will see what happens. Thank you very much for everybody. It was absolutely great to meet you and just discuss this nice subject. And this is it. Maybe we just meet other meeting next year or something like that.
Hopefully.
I would like to say something that if we are here in such an excellent group, I would like to invite all of you to group photo, and I invite all attendees as well. So you should now see the example of selfie. So just take a photo and we can create our virtual group photography.
Just remember to look into the camera.
So I think that's a nice souvenir from today. Excellent debate. So thank you once again for being here with us.
Okay.
And I encourage all people to join, not only our speakers, but you are all invited to do it with us. So it's the one and only opportunity to make a photo with all of these great people, like never again.
Hi, Dan.
Oh, I see. Perfect people.
Okay, so will you email the group photo to all of us?
If
you will receive it automatically, like every one of you, to your email. So that's how this platform works. So I think it's quite nice. So you will all receive it. Oh, we have 16 people, and it's counting. So we can wait just 1 minute more to have this group photograph.
Well, while we're waiting, I'd like to say thank you to everybody. It's been a very enjoyable panel.
All right. Yeah,
Thank you very much for having me.
This has been fantastic.
Thank you very much for everybody here. And some day I hope they just go to a nice evening. Some day just have a nice day, and I go to sleep.
Okay, so
We have a pleasure.
18 people. If someone would like to join, last 10 seconds, because I need to end it to our photo. And I think that would be it. So here you can find your group photo. All of you should now see it.
Excellent.
Okay.
So thank you once again.
Thanks so much. Bye.
Thank you.
Thank you. Bye bye.
Bye bye.